All right, in the last set of notes, we looked at this acronym. Corresponding parts of congruent triangles are congruent. Or sometimes I remember the acronym by remembering cuddle puppies because they're cute. Or I pronounce it and it kind of sounds like an alien language. I say sptk. It's fun to say. You should try it. Sptk. But corresponding parts, or remember that means matching parts of congruent triangles, are also congruent. Okay? So let's look at an example of how we apply that. If I know that triangle JK or LKJ is congruent to triangle QMP, I can use corresponding parts of congruent triangles being congruent to fill in all the missing measurements. Remember, there are 3 angles in each triangle and 3 sides of each triangle, so 6 total measurements in each triangle. If I look at my congruence statement, I can see my first letter L is going to match up with my first letter Q. So that means angle L will match up with angle Q. And I don't know either one of those, so we'll have to come back to that one later. Then I have angle K corresponds or matches with angle M. So angle K matches with angle M. So since I know K is 78, I know M is also 78 degrees. Okay, then my last letter there tells me about my last set of angles. My last letter is letter J, and that's going to match up with letter P. So letter J will match up with letter P, which means they will both be 52 degrees. Okay, so we still haven't found L and Q. But remember, math and geometry in general, and really all math, is cumulative. You have to remember the other stuff you've learned. And we learned in middle school, and we reviewed it last week, the triangle sum theorem that says the 3 angles in a triangle together are going to add up to 180. So I know my 52 plus my 78 plus whatever this is going to add up to 180. My 52 plus my 78 plus whatever this is going to add up to 180. So my 52 plus my 78 plus whatever those missing angles are is going to add up to 180. Okay, so I'm going to take my 52 and my 78 and I'm going to add those together to get 130 plus x equals 180. I'm going to subtract 130 on both sides, which is going to tell me that that missing angle that I wasn't sure of is going to be 50 degrees. And that's going to be true for angle L, and it's going to be true for angle Q. Okay, so we have all our angles figured out. Now let's look at our segments. Again, order is important, and order tells us what the corresponding or matching parts are. My first 2 letters are L and K, from L to K, and I know that's going to match up with Q, M. Q, M. So it's important to notice, right, these triangles have been rotated and flipped around. So LK is going to match up. These are going to be our matching parts. So if this one's 40, this one will be 40. Okay? That's why it's really nice to have these, is because when these pictures are rotated and flipped all over the place, it's really helpful to be able to just use your congruent statement to be able to find what goes with what. Okay? So then I'm going to look at my second 2 letters, K and J, and that's going to match up with my second 2 letters, M and P. M and P. So my second set of letters are going to match, which means they're both going to be 39. Okay, and then for my third set of letters, we look at the outside letter in each side. So my L and my J, L to J, will match up with Q, P, Q to P. So my third sides will match up. If one is 50, the other will also be 50. Okay? So that is using CPCTC to find missing parts of triangles. Okay? So now we're going to get back to something we haven't done in a while. We're going to look at a couple of proofs. Okay, and we're going to add CPCTC to our proof, and then we're also going to talk about making that switch from things being congruent to things being equal, because we haven't really talked about the difference really in a proof on equals and congruent. So we're going to look at that real quick. Okay, remember in geometry when you're asked to prove something, you have to write down what you've been given and how you get from each step to the next step in your work. So the first thing we're going to start with is our two columns. So I'm going to have a statement column, and I'm going to have a reasons column. Okay, and I'm going to start with my givens. My givens are triangle RAT is congruent to triangle DUC, and that is given to me. Okay, and then the measure of angle R is congruent or is equal to x minus 52 degrees. That was given to me. And then my last given here, the measure of angle D is equal to 78 degrees. That was also given to me. Okay, so then what I do is I can draw a picture if I want to, but that congruent statements are super helpful. Sometimes they're so helpful you don't really need to draw your picture. Sometimes they're so helpful we can just look at the congruent statement. And then I'm looking at, what am I looking at? Angle R and angle D. So look at where angle R is in my congruent statement and look at where angle D is. They are in matching or corresponding positions. So that means this angle is a corresponding angle to this one. These are corresponding parts in congruent triangles. And we know that corresponding parts in congruent triangles are congruent. So that means I can say these two angles are congruent. So I say angle R is congruent to angle D. And the reason we can't go straight to the measures being equal is because this theorem involves congruence and not equals. Okay, so before I can substitute in the value for R and the value for D, I have to talk about these being congruent and how do I get to them being equals. So here's how we do that. We just go now to them being equal. We say, okay, if these are congruent, the definition of congruence, if you want to define it, is congruent things have congruent or have equal measures. So congruent angles, which is what we have here, angle R is congruent to angle D. Congruent angles have equal measures. So that means the measure of angle R is going to be equal to the measure of angle D. And then what do I put over here? Well, what did I say I was doing to get from here to here? I looked at the definition of what does congruent mean, right? I looked at the definition of congruence, and we were working with angles. So I'm going to say the definition, and I'm going to abbreviate, of congruent, and I'm going to use my symbol so I don't have to write out the whole word. And then what are we talking about? We're talking about angles. So the definition of congruent angles. It's real important that when you're doing this, you pay attention to what you're looking at the definition of. Here I'm looking at angles, so it's a definition of congruent angles. If I had been comparing sides like RA and DU would be corresponding parts that we could say were congruent, then this next line would change and I would say the definition of congruent segments, because then I'd be working with segments. So make sure this word here matches with what you're working with. I'm working with angles, so I said definition of congruent angles. So now that I've done that, I can substitute in, because I know what the measure of angle R is. It was given to me. It's x minus 52. I know what the measure of angle D is. It was given to me. It's 78. Okay? And all I did was substitute my values in for what they equaled. So substitution, property of equality. Remember, if you abbreviate, make sure I can still tell if it's substitution or subtraction. Okay? All right, so then the next thing I'm going to need to do is get that x by itself. I'm just going to add this 52 to both sides. And remember, this part that I'm doing in pencil is not really part of the proof. that's normally not in there, but just so we can see how I got there. That goes away and I end up with x equals 78 plus 52 is 130, which is what I was trying to prove, but I do not write the word prove here, right? How did I get from here to here? I can see it. I added 52 on both sides, so I use the addition property of equality. Again, if you put prove here, it's going to be wrong every single time, so do not put the word prove here. Just because we put given for our givens does not mean we put prove for our proof. All of this together is the proof. Okay, you'll never see the word proof in your proof. How did we get from the second to last step to the last step? I added 52 on both sides. Okay, let's do one more of these. All right, so when I look at the next one, number 2, I am given triangle ADB is congruent to triangle CDB. And I'm trying to prove that y equals 7.5. So I'm going to have my statements, and I'm going to have my reasons. Okay, now this time, some of my givens are here in the picture for me. So I need to make sure I look at the picture so I can make sure I get all of my givens that I know. First thing I've given is my congruence statement. I know that triangle ABD is congruent to triangle CDB. That's been given to me. Okay, then when I look at the picture, I can see that AB, segment AB, or AB, the distance from A to B, is 7y. That's given to me by the picture. Okay, and then I can see that the distance from C to D is 3y plus 30. And notice I said C to D because I'm kind of trying to think ahead. And I know if I'm looking at A, B, those are the first two letters. So I'm going to look at the first two letters, C, D. So I can call this DC, but it's going to be easier in the proof if I try to stay consistent with my labeling. So I'm going to call this one CD. And in my picture, I can see it's 3y plus 30. And that is given to me. Okay, so that's what's been given to me. Then what I want to do is I want to look and see if those two pieces that have been given to me, are they matching? Are they corresponding parts? So AB is my first two letters, and CD is also my first two letters. So these are corresponding parts. Okay, and since we're going to be saying corresponding parts of congruent triangles are congruent, that means we have to deal with congruence. And when we deal with congruence, we have to deal with shapes or figures, not lengths or distances. So I have to talk about the segment AB being congruent to the segment CD. Okay, and then just like the last one, I can't plug in AB for segment AB. I can't plug in CD for segment CD. But I know the definition of congruent means that congruent figures or congruent things have equal measures. So if I have congruent segments, then I can say the distance from A to B is going to be equal to the distance from C to D using the definition of congruence. Now, remember I said you have to determine what is congruent. Up here, I use definition of congruent angles because we were looking at congruent angles becoming equal measures. Here I'm looking at congruent segments becoming equal lengths. So definition of congruent segments, because I'm working with segments. When you're working with angles, you use angles. When you're working with segments, you use segments. Okay? All right, so now all I have left to do is I can do my substitution. So AB can replace with 7y, and CD can be replaced with 3y plus 30. And that is substitution, property of equality. Okay, and just make sure that you can, if you abbreviate, you don't abbreviate so much, I can't tell the difference between substitution and subtraction. Because on this one, we are going to need to subtract, right? I'm going to subtract 3y on both sides. And again, this part in pencil is not technically part of the proof, so that does not get a reason written next to it. I'm going to end up with 4y equals just 30. I subtracted 3 on both sides, so that's my subtraction. Property of equality. Again, if you abbreviate, make sure you can tell the difference between your substitution and your subtraction. And then last but not least, to get rid of that 4 in front of the y, I am going to divide both sides by 4. And y equals 30 divided by 4 is 7.5, which is what I was trying to prove, but I do not put the word proof here. What did I do to get from here to here? I divided both sides by 4, so the division, property of equality. Okay, never end your proof with the word proof. The whole thing here is the proof. All of this together is the proof that y equals 7.5. Okay? All right, so hopefully that helps you with CPCTC. There are a few assessment questions and a proof you will need to complete. All right, thank you so much for watching.